Assalamu alaikum students, hope all of you are fine. We are continuing our lesson 2 that is about total internal reflection. Here we are discussing the critical angles of different materials including total internal reflection. For glass its value is 1.5 to 1.70, critical angle is 30 degree to 42 degree. Water refractive index 1.33 and critical angle 49 degree. Perspex so 1.5 is the refractive index and critical angle is 42. Diamond refractive index 2.42 and critical angle is 24 degree. We will discuss the applications of total internal reflection, but before that we were going to see a video that how total internal reflection occurs. Girls, see this video very carefully to understand the practically that how total internal reflection occurs. Let's start it. In this video, we will study the phenomena of total internal reflection in a semicircular glass block. And when we incident the light ray at different angles, at a certain angle, the total internal reflection or TIR will occur. See this. As the angle of incidence increases, angle of refraction also increases. We have started from 0 degrees Celsius. And when comes a critical angle, after that, there will be total internal reflection. See that there is a weak reflected ray inside. When there is total internal reflection, no ray will refract. There will be no refraction when there is total internal reflection. And you can see that the laws of reflection are also applicable here. The angle of incidence is equal to angle of reflection. The incident ray, the normal, and the reflected ray all lie in the same plane. As from the experiment, I think it's very clear to all my students that we have started from 0 degrees Celsius angle. As we increase the angle, refraction occurs. But after coming to critical angle, when angle of refraction becomes 90 degree, there will be no more refraction. To all the light will be totally internally reflected. Now these are the now we will discuss the applications of total internal reflection. Total internal reflection has many applications in the field of communication as well as in the field of medical industry. The first main application of its optical fiber communication. As we know that all our telephonic lines are also replaced by optical fiber cables. Previously, copper cables were used for telecommunication process. Second important application is prism used in binoculars for producing erect images. Erect means upright, okay? And third is endoscopy. Maybe you have heard the word of endoscopy, we will discuss it. And fourth is for the jewelry purposes. As we have seen, the refractive index of diamond is very much high as compared to other transparent materials. So it's also used for the jewelry purpose. As we can see, first TIR in diamonds, that is total internal reflection in diamonds. Sparkling of the diamonds is due to number one, the cut of diamond faces. As we cut the diamond faces in a different way, so that total internal reflection occurs in it and it will sparkle. Second is high index of refraction, which means a very small critical angle. When always remember when critical angle is high, is very large, the index of refraction is low. When index of refraction is high, the critical angle will be low. Okay, so see that the refractive index value is just is 2.42, which is high as compared to the substances when critical angle is 24.4. incident rays can undergo multiple TIR. There is no a single total internal reflection. There are multiple total internal reflections inside a diamond before exit for exiting the top of the diamond. That's why it sparkles. The second important application of total internal reflection is in fiber optics. Now you have seen these fiber optics in your daily life, maybe in some decoration pieces or in some videos. Technology that uses light to transmit information along glass cables is known as fiber optics. Now in this, why we use glass cables? Because we need transparent medium for total internal reflection. So we can only use a transparent material that can be a glass or that can be a plastic. Fiber optics cables is made up of a bundle of glass fibers. Sample materials are high purity glass or lacquer. Now, TIR and fiber optics have these advantages. Advantages number one, signals are not affected by electrical storms. They're not affected by even electrical storms, that if there is more electrical charges or less electrical charges, there's no effect on the fiber optics. Cable is smaller and lighter than copper cable. And very important, that light copper cable or the other metal cables have higher resistances. But as copper cable is smaller and lighter than that, so it's more reliable to use. More signals can be carried over long distances. The very important point in fiber optics, there is no change in the intensity of the light. The whole light intensity is transmitted without any loss of intensity. So we can transmit more signals to more longer distances in a short time, as well as a lot of communication calls can be transferred without disturbance due to optical fibers. The fiber optics in endoscope. This is very important application in medical industry. An endoscope is actually a flexible fiber optic cable through which internal cavities can be viewed. For example, if you want to examine something inside your stomach, then we can use endoscope, routinely used in the diagnosis of cancers and ulcers. We will view it in the next slide, that endoscopic examination of stomach. Endoscope is inserted through the patient's mouth and fed down through throat. Okay, image obtained by endoscope is projected on a screen. Now, where is that screen? On the other side of that optical fiber and endoscope, a small camera is attached, and the next side there is a screen which is projected on your computer screen. Now, a surgical instrument for obtaining a biopsy has been fed through the endoscope cable and controlled by the doctor. The process by which we examine the stomach by endoscopy is known as gastroscopy. Okay. Now, these are the totally reflecting prism. There are two types of totally reflecting prisms as shown to you. They are also, you have these diagrams in your book also. Go through them, try to understand them. A right-angled prism or totally reflecting prism is a prism in which one of the angle is of 90 degree and other two angles are of 45 degree. When a ray of light perpendicular to the side of the reflecting prism is incident, as it's in the direction of normal, there will be no refraction. It will directly strike the front side. When you will draw the normal, it will always make an angle of 45 degree. According to arithmetic rules, if there is a right angle triangle having two 45 degree angles and one 90 degree angles, we are going to cut it through a parallel line. Then when we draw the normal, the angle is also 45 degree. Now 42 degree is its critical angle of this prism. As angle of incidence is greater than 42 degree, so total internal reflection will occur in this prism, and the angle of incidence will be equal to angle of reflection, and total internal reflection will occur and light ray will come out as it is fed into the prism. So total reflection of 90 degree occurs here. These prisms are more useful than mirrors because it reflects almost 100% of light internally. Mirrors lose some light through absorption, and emergent can be 90 degree or 180 degree. In the first prism, there is total internal reflection of total angle through 90 degree. Here in this, when we put it in this way, this prism in this way, when the light ray is in the direction of normal, again there will be no refraction as the angle of incidence is 0, angle of refraction is 0. At the point of incidence, draw a normal. This dotted line is normal. This angle is 45 degree. Definitely this will also 45 due to total internal reflection. When this ray of light strike the other side, here also the angle made by it is 45 and angle of reflection is also 45. So total 90 degree reflection here, total 90 degree reflection here, 90 plus 90, it comes to be 180 degree. So these are the two types of totally reflecting prism used in many objects. You can see here the total reflecting prism. When the different light rays are incident, there will be a, when it is incident on it, it will refracted, and then it will be totally internally reflected in the prism. Now, these prisms are basically used in periscopes or also in many other microscopes. Instrument for observation from a concealed position using two triangular prisms to change the direction of light by 90 degrees. Girls, you have to draw these diagrams on your notebooks also. As light enters the prism, the rays enters the prism, it's totally internally reflected through 90 degree. Then it's incident on another prism, again 90 degree, 90, 90, 180. It is basically used in war and in submarines. Now these prisms are also used in binoculars. Uses two prisms to change direction of light by 180 degree. You can see here if the prism are just placed with each other, like from base to base, the light ray enters, totally internally reflected by 90 degree, then it enters the other prism, again 90 degree, 90, 90, 180, 180 through 360 degree. That is in binoculars, that is by the same process. Sorry. Prisms in single lens camera, it's also present in your book, that there these cameras are known as SLR, single lens reflex camera. The five-sided pentaprism reflects light from the mirror into the eye. You see the light is first incident on the mirror, which is placed inclined at an angle of 45 degree. As reflection occurs, due to deflection, the light ray enter the pentaprism in such a way that there is no refraction in when it strikes this surface along the normal. It's totally internally reflected twice, and then it enters through the lens, and then it enters through the eye, and the image is formed on the film. Now we are going to solve one or two questions related to the TIR. A ray of light traveling in the direction EO in air enters a rectangular block at an angle of incidence 30 degree. The resulting angle of refraction is 18 degree. Find a refractive index N of the block. You have to find the refractive index N. The angle of incidence is 18. The angle of incidence is 30 here. The angle of refraction is 18 degree. Okay, now you have to find the refractive index of the block. Again, you have to use the formula n1 sine theta 1 is equal to n2 sine theta 2. You will write the given all the material, then put the values. Sine theta 1 is actually angle of incidence is 30 degree, angle of refraction is 18 degree, and for air, you know that refractive index is 1. We will put the value of n1 as 1, n2 we have to find out, and by calculations we will find out it is 1.62. Find the critical angle C for the block. You have to find the critical angle for the block. Second medium is air, then we use simply C is equal to 1 over sine inverse 1 over n, or 1 over n is equal to 1 over sine C. For that, what is given? For critical angle C for the block, we have angle of incidence must be, angle of refraction must be 90 degree. The refractive index of air is 1. The refractive index of block we have discussed is 1.62. So again we apply all the formulation on the same formula, and we will get the value of theta 1 as 38 degrees. So critical angle of this glass block is 38 degree. 90 degree is not given, it's for sure that angle of refraction is always 90 degree when there is a critical angle, and we have to find the critical angle for this. And for air, refractive index is 1, and for the glass block we have find it as 1.62. Second question is, if the ray is incident on surface BC, from which surface and from which surface and at what angle will the ray leave the block? They have only given you the incident ray entering, and they have also given you this angle. This angle is not angle of incidence. Angle of incidence is always between the incident ray and the normal. So this will be the angle of incidence. It will be 60 degree. And then how we will solve it. First of all, we will see it that this question is continued with the previous one. As for refractive index of air is 1, for block we have find out as 1.62. Here's the theta 1. Theta 1 is 60. This is the angle between the incident ray and the normal. 1 into sine 60 degree is equal to 1.62 into sine theta 2. Sine theta 2 is equal to sine inverse 1 over sine 60 over 1.62. So the angle come out to be 32.3 degree. The next is, if the ray is incident on surface BC, from which surface and at what angle will the ray leave the block? So here we have angle of incidence as 60 degree, critical angle we have calculated in previous 38.1, angle of refraction is 32.3. Now we know that this angle is 30 degree. Now we have find out that angle of refraction 32.3. We draw the refracted ray, then we will draw the normal, and we find out this angle. This angle comes out to be 57.7 degree. Okay, and an angle is greater than, of course, critical angle. The critical angle we have calculated is 38.8. So here total internal reflection occurs. So light will continue from that. This angle is 57.7. This is also 57.7. Okay, from here you will draw the normal and you will measure this angle. This angle comes out to be 30. This angle and this angle should be same, as this angle is same mathematically. So the emergent ray, as we had discussed before, the emergent ray and the incident ray, they will have the same angle. Now there is an MCQ related to that. Which of the following angles is the critical angle of glass? I've told you this comes many times in the MCQs. Which one is the critical angle of glass? For that you have to see, this is the angle of incidence. Here they have marked theta here. This is not. If this is marked, then this option can be right. So this is not right here. B, theta, this is not a critical angle as they are in rare medium. Light ray must enter from denser to rare. Yes, it's entering from denser to rare. And second, the angle of refraction in rare medium must be 90 degree. Here it is 90 degree. So this theta is definitely critical angle. And when we move here, it is TIR, but it's not critical angle. At critical angle, the angle of refraction becomes 90 degree. So answer will be our C part. Let's do a recap. Use of, first we have discussed about index of refraction in today's lesson. We have discussed that how we use n is equal to sin I over sin R. Then we have discussed critical angle, the angle of incidence for which the angle of refraction becomes 90 degree. Then we have discussed TIR. It has two conditions. The light ray must enter from denser to rare medium. And secondly, the angle of incidence must be greater than critical angle. And then we have discussed the applications of total internal reflection in detail. I hope so all of you have understood this lesson very well. Thank you so much, girls, for staying with me. Take care of yourself. Allah Hafiz.